here's two functions, la la la, and the graphs intersect at this point. Find the values of P and Q. So if they intersect is where those graphs meet. Well, it's the calculated paper, so we're just going to plot those two. So we've got alpha y equals 9 over x plus 2, and then 3x squared. Okay, they haven't given us any values, so let's go up and see if we can see them. Okay, so hopefully it's obvious we're looking for this point here. So second calc, intersect. So get close to the intersecting point. And it meets at 1, 3. So that's the, so P is 1, Q is 3. Write down F dash P. Okay, F. So we're trying to F dash X. So that's 9 over X plus 2. Now, some people got confused thinking this is a quotient rule, but it's not, because there's only one expression here on the bottom. The top doesn't have an X in it. So I'm going to rewrite that as this. And, oh, that's Fx, sorry. And now I'm going to differentiate. So the power comes in front. Take one off the power. Multiply by the derivative of what's inside, which is just 1. So we've got just negative 9x plus 2 to negative 2. We need to find f dash p. So p was 1, so we're going to stick 1 into here. So let's quit that. So we've got negative 9 multiplied by 1 plus 2 to the power of negative 2, which is negative 1. Okay, let L be the normal of the graph. Find the equation of L. Okay, so f dash p talks about the gradient of the tangent. So if the gradient of the tangent was negative 1, then the gradient of the normal is going to be positive 1. But we need to find the full equation. So we need to know what point it goes through. Well, luckily we do. So we've got y equals, okay, 1x plus c. We know it goes through the point 3, 1. And so c is 2. And so the equation is y equals x plus 2. Write down the y-intercept of L. Well, hopefully you're fine with that being 2, or the 0.02. And last question. So first two terms of geometric sequence are blah blah. Find the common ratio. So we're going to do 4.2 divided by 4. Oops, not 42. So it's 1.05. Hence or otherwise find U5. So we're going to use our formula. So it's a geometric sequence. So we've got 4 multiplied by 1.05 to the power of 4. Let's do that in our calcs. So I guess we need to write, we can write a whole value. Oh, I don't know what it was. Oh, darn it. Oops, wrong one. that's the answer there. Okay, another sequence is defined with blah, 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 such that v1 is this and v2 is this. Find the value of a. Okay. So we know that a multiplied 1 to the power of k is 0.05, and a multiplied by 2 to the power of k is 0.25. Okay. Right, if we're trying to solve this, then so 1 to the power of anything is obviously going to be 1, so we know from this one that a is 0.05, and so 0.05 multiplied by 2 to the power of k equals 0.25. That's from this one. So 2 to the power of k equals 0.25 divided by 0.05. 5. So 2 to the power of k equals 5. To find k, we have to take logs of both sides. So it can be any kind of log, base 10, natural log, whatever. So we've got k, perhaps I should write it out properly. So we've got log 2 to the k equals log 5. K log 2 equals log 5. K equals log 5 over log 2. So log 5 divided by log 2 is 2 point. Oh, I should do that again. There we go. C, find the smallest value of n for which Vn is greater than Un. Okay, so you've got different ways of doing this. I think I would probably just plot them and see where they were equal, or see when one is greater than the other. So V is this one, so if I do that one first, so that is 0.05 multiplied by n, which is our unknown, to the power of 2.32. So that's one function, and then the other one was, okay, so we can use this. So 4 multiplied by 1.05 to the power of x minus 1. Okay, so let's graph that. So that's our first function. So we need that one to be greater than the other one. Okay, so the first time that this one is greater than that is after here. So if we find where they intersect, enter, enter, enter. So they meet here at 7.59, then it has to be a whole number, because it says here that n is a positive integer. So it would have to be n equals 8. And you can, as your method, you could sketch this here. And show that that value was whatever it was. 7.59. Obviously I'm pasting all this because I can't bother to keep writing it. So you can show that that was a value, and so the n was a value of 8. Okay, there's the paper done.